Okay, in this video, I would just like to take some time to give a brief overview of Module 3 Learning Goal 7, which is division of fractions. One of the things we need to keep in mind as we begin this division lesson is that we want students to remember what they learned about division back from number sense 1 and 2. So if we have 18 divided by 6, those are whole numbers. But back in number sense 1 and 2, they learned the whole copies of mentality. So when they see something like 18 divided by 6, they should be thinking, how many copies of 6 are in 18? There are 3 copies of 6 in 18, therefore 18 divided by 6 equals 3. So keeping that copies of mentality will really help them when we get to the division of fractions. Because remember, our goal is to help them understand what it means to divide fractions. Not just to have them blindly memorize, invert, and multiply, because then they don't understand why they get the answers they get, and they don't understand what they're doing, and quick little shortcuts like that are easily forgotten by students. Okay. The next thing we want to remember as we begin this Module 3 and as we begin this lesson is that we need to think of our fractions in terms of copies of as well. So if you see here, if we just consider the fraction 3/4, we need to think of 3/4 as 3 copies of the fraction 1/4. So if we look at it with the fraction circles, if we think of the red circle as our unit, then we can consider 3/4 by using our yellow pieces. So if the fraction circle, the red circle is our unit, then 3 of the yellow pieces put together would be 3/4. And there is our 3 copies of 1/4. So we want students to realize that the number 3/4 represents 3 copies of that 1/4 piece. So they can think of it put together as missing that one chunk, or they can think of it as 3 separate copies of 1/4. So in general, any fraction a over b should be thought of as a copies of the fraction 1 over b. Okay, so the next thing I wanted to do is I just want to look at a basic fraction division problem. Something simple like 4 divided by 1/2. Now, I don't know about you, but in the past, I've had a lot of students who look at that and they say, oh, that must be 2, because they think they're taking 4 and cutting it in half. Or I'll even hear them say 4 divided by half is 2, because if you cut 4 in half, it's 2. So they're not understanding that dividing by 1/2 is something completely different than multiplying by 1/2, which is what they're thinking when they say cut it in half. Okay? So again, if we're thinking of the copies of idea, if we have 4 divided by 1/2, the students need to be asking themselves, how many copies of 1/2 are in 4? So I think if they think about it that way, it's a little bit easier for them to understand. And again, keep in mind that we're not leading with that invert and multiply, or multiply, change division to multiplication and invert the fraction. We're not starting with that algorithm. That doesn't come till much later, until the students really understand how division works. So we wouldn't want to lead with that in a problem like this. We wouldn't want to lead with that division algorithm because we want them to discover it later. So we have how many copies of 1/2 are in 4. So here's my 4. Okay, and so if I want to know how many copies of 1/2 are in 4, I want to look at my piece that represents a half, and I want to see how many copies of 1/2 can I fit in the number 4. And so by having the students lay the shapes out, they can see conceptually why 4 divided by 1/2 is 8. So here is my 8 halves. So 8 copies of 1/2 in the number 4. And again, we wouldn't show them that, oh, it's because you change division to multiplication and invert 1/2 and get 4 times 2 over 1. We really want them to understand the concept. We're trying to figure out how many copies of 1/2 are in the number 4. So they can clearly see here that it would be 8. Okay, let's move my fraction pieces. All right, so the module begins with a coffee problem. So let's take a look at it. So we have a local coffee grounds packaging company packages 3 different types of coffee. They package a premier variety, an economical variety, and a blend of the premier and economical. Each pound of the blend contains 1/3 pound of the premier coffee and 2/3 pound of the economical variety. If the company has 4 7/18 of a pound of premier coffee available for blending, how many pounds of the blend will it be able to create, assuming it has an unlimited supply of the economical variety available? So again, in this, we're not expecting students to come up with the answer right away. This is more of an introduction that we will return to later in the module, or later in the lesson. But we at least want them to start thinking about what do they need to understand here, or what do they need to figure out in order to be able to answer this. We don't necessarily need them to come up with an answer right away. So, you want to, give them some time to think about it, or maybe have a class discussion. But this is how I, interpret that. Zoom out a little here. Okay, so in the problem, it said that the company has 4 7/18 of a pound. So my question, or the student's question, should be how many copies, I can't see that, how many copies of 1/3 for the 1/3 pounds, how many copies of 1/3 are in 4 7/18? So if they can think about that, again, we don't necessarily have to get to an answer right away. At least we're conceptually getting an understanding of what it is we need to know to be able to answer this problem. So for me, each circle here would represent a hole. So here's my 4 holes. And then I didn't do the best job of splitting up this 5th hole into equal 18 pieces. But so let's just pretend those are 18ths. And so if we had 4 7/18, we would have 4 of these, and then we would have 7 of these. So here would be my 4 7/18. So that's what I have. I have these 4 holes plus this shaded part, which is the 7/18. So if I want to figure out how many copies of 1/3 are in those, I need to think of my 1/3 pieces. And these are a little bit bigger, but, hopefully the students would be able to realize that for each whole pound, they can get 3 copies of 1/3. So they can get 3 copies of 1/3 right there, another 3 here, another 3 here, another 3 here. And then we would see how many copies of 1/3 can we get out of this. Well, keep in mind they will have already learned about equivalent fractions, so hopefully they would realize that 6 of those 18ths would be 1/3, would be equivalent to 1/3. So they would have the 12 copies of 1/3, these 4 holes, and then we could get 1 more copy of 1/3 out of that, out of those 7/18. And then of course we would have that 1/18 left over. So that would just aid, or that would just add to the discussion of, how many pounds of the blend would they be able to make? Well, they would be able to make 12 from these right here, plus 1 hour, so they would be able to make 13, and then they would have a little bit left over, but that wouldn't be enough to make 1 more pound of the blend. But again, they don't have to necessarily come up with the answer straight away. It's just more of a getting them to think about what they even need to visualize to be able to answer a problem such as this. Okay, I'm going to stop this video right here because it is getting a little long now, and then I'm going to start a new one that will use some of the Cuisenaire rods so you can see how we work with those Cuisenaire rods.